Given the complex numbers u and v, we are to express u and v in the simplest form. U over v, that is given by -4 plus 2i over 3 plus I. And to express in the simplest form, the denominator must be a real number. So we multiply by the conjugate of the denominator, which is 3 minus I. And we do the same for the numerator. Expanding the numerator, we have -12 plus 4i plus 6i minus 2i squared. In the denominator, this is just a sum of squares, so we have 3 squared plus 1 squared here. -2i squared is, I squared is -1. So -2i squared becomes +2. -12 plus +2, that is -10 plus 10i. In the denominator, that is a 10 as well. So we have -1 plus I for u over v in the simplest form. Part B, we are to express u over v in the form of r e to the I theta, where r and theta are exact. So r is just the length of this -1 plus I, then r is the modulus of this, which is -1 squared, plus the coefficient of I is 1, and we have r equals square root 2. To find theta, let's look at this complex number here. On an argon diagram, -1 plus I is located here. So this is the complex number -1 plus I that we have. And this is the angle theta that we need to find. So in order to find this, from the argument of a complex number, we know that the argument is the arctangent of 1 over -1. So this will give us the arctangent of -1. The angle is obtuse. Arctangent of 1 is pi over 4. Arctangent of -1, this is 3 pi over 4. Then u over v can now be written as square root of 2 e to the 3 pi I over 4. In an argon diagram with the origin O, the points A, B, and C represent the complex numbers u, v, and 2u plus v. For this part C here, we can let vector OA, we can represent the complex number u by a vector OA, and then vector OB can be complex number v, and vector OC can be the complex number 2u plus v. Part C, we need to state fully the geometrical relationship between OA and BC. Now from here, OC is 2u plus v. So OC, if this is 2u plus v, u is vector OA, and then v is vector OB. So we can write this as vector OC minus vector OB. This is 2 times vector OA, and this will give us vector BC here. So from here, okay, we have vector BC. So OC minus OB, that will give us vector BC. and this is twice of vector OA. Then, if vector BC is twice of vector OA, then we say that BC is parallel to OA, and we have BC equals 2 times OA for part C. For part D, you need to prove that angle AOB is 3 pi over 4. For part D here, if we look at the Argand diagram, OA is vector U, which is complex number U, which is -4 plus 2i. So this is point A, and we actually have vector OA in this manner. And vector OB is complex number V, which is 3 plus I. So we could have a complex number B here. That is point B, we have vector OB. Now that is the angle AOB. We need to show that this angle is 3 pi over 4. It's easier to find an angle between two vectors. So let's say vector OA. We convert this into vector form. We have -4 and 2. And then vector OB converted to vector form, we have 3 and 1 here. To find the angle between two vectors, we use the dot product. So the dot product of vector OA and vector OB, this is given by the product of the magnitude of vector A, the magnitude of vector B, cosine of the angle between them. So we have cosine of AOB. We can write this on the left side. Magnitude of vector OA is the square root of the sum of squares. So we have 16 plus 4. Magnitude of vector OB, we have square root of the sum of squares. We have 9 plus 1. Cosine of AOB. So this is given by the dot product of -4, 2 and 3, 1. That will give a square root of 20, square root of 10, cosine of AOB. So this is -12 plus 2, and that gives us -10. That will give us square root of 200 cosine of AOB. So that cosine of AOB is -10 over square root of 200. Square root of 200 is square root of 2 times square root of 100, which is 10 square root 2. So that cosine of AOB is -10 over 10 square root 2, which is -1 over square root 2. Since cosine of AOB is negative, we know that AOB is an obtuse angle. Then the reference angle is given by inverse cosine of 1 over root 2, which is pi over 4. Angle AOB now is pi minus pi over 4, which is 3 pi over 4.